We're going to be doing a virtual lab on voltaic/galvanic cells. And before we get into your lab data, I just want to go through some things here. On our left-hand side, you can see that we have our activity series, which shows us the ease of oxidation increases as we go up the chart. So when we pick two metals, and I'm going to pick copper and silver, there will be a choice. Which one will be our anode and which one will be our cathode? Our anode is oxidation, so the one on top will oxidize more easily, and that will be our anode, and the one on the bottom will be reduced. There are also numbers that go along with this called reduction potential numbers. We're not going to get into that, but if I added up the reduction potential numbers, we would have a difference, and that is our electricity in volts that's shown on top here with our voltmeter. So if you were going to do those calculations, you'd have reduction potential numbers, and the difference would be what we get here in volts. If there is no difference, if I put copper and copper, nothing will happen. So let's first start with copper and silver. So I'm going to pick copper on the left because we've been looking at anodes on our left. That doesn't always have to be the case. It's going to be in copper nitrate. And then we'll look at silver on the right and silver nitrate. Now, what we're going to expect here is that our copper will be oxidized, which means it's going to lose its electrons. It's going to flow to the cathode, which will gain those electrons, and then our ions in solution will take those electrons and plate on the silver electrode. So here we go. Our copper is being oxidized because it's our anode. It's losing those electrons. And our silver is being reduced because that's our cathode and electrons are going there. And the silver metal is plating onto this cathode. And we can see that on a molecular level. Here is our anode and our electrons are being lost and copper is going into solution as ions. And then on a molecular level for our cathode, our silver is grabbing those electrons and plating on a solid metal on our cathode, and that's why we say cathode CRAP, cathode reduction and product, making product here, and you can use the acronym for our anode as ANOX, anode oxidation. So when you saw this number up here for our volts, which you will be recording, that's the difference in reduction potentials. So I don't want you to get used to anodes being always on the left side. So I'm going to turn this off and I'm going to change that, and I'm going to do the same thing, only I'm going to flip it. So I have silver over here, and that's going to be in silver nitrate. And I'm going to put copper over here, and I'm going to put that in copper nitrate. Now, still looking over at our table, copper is going to be oxidized because it's on top, and this table shows us ease of oxidation as we go up. And so if it's oxidized, it's going to be our anode. So here you're going to see the same reaction just flipped. Our anode is on the right and our cathode is on the left. And we get our 0.46 difference in reduction potentials. And again, our electrons are going from our anode over to our cathode, where the metal ions in solution is being plated onto that cathode. So nothing's changed. We still have our anode and our cathode. We just reversed the beakers, and everything we've learned still holds true. So what happens if I put two copper electrodes on there? There is no difference in ease of oxidation. There's no difference in reduction potentials. So we would believe that nothing would happen. There isn't anything here that has a stronger pull on those electrons. So when I turn it on, you can see absolutely nothing happens, and there's no electricity being made, so no volts on our voltmeter. So the first pair that you were to do in your lab data table was copper and silver. You can rewind this video and see what happens and fill out that chart. The next one that you are going to do in your lab is silver and zinc, and here I have that set up. And I will turn on the meter and you can get all the data and fill in your chart. Which way are the electrons flowing? They're flowing this way, so you need to determine which one's your anode and which one is your cathode. The next one that you are going to do is zinc and copper, and here I have it set up for you. Let's see what happens. Which way will the electrons flow? It looks like they're flowing from zinc to copper. So the last part of this lab, we are going to compare the cell's voltage for the different cells we make. So you've already done the first two. You're just going to transfer the voltage down. And the last one, the cell that you're going to make, the voltaic cell, is hydrogen and silver. So I have that set up here, and I will turn on our voltaic cell. And you can see the electrons are flowing from the hydrogen to the silver. That means hydrogen is being oxidized, it's our anode, and our silver is our cathode. It's being reduced, and product is forming on that cathode.